An ID column is a column that's used as a unique identifier for each row in a table. It's commonly used in relational databases for connecting one table to another. For this lesson, we're going to use the Scratch database. And again, I'm going to copy from the exercise files. This is the Chapter 3 exercise file starting around line 100, starting with this drop table if exists, because again, we're going to be creating this table over and over again with different options, all the way down here through this show indexes from test on line 113. So I'm going to copy that and paste that into our SQL box here. And you notice I'm creating a table with 3 columns, integer and 2 varchars. And I'm inserting some rows into it and then selecting from it. I'm going to describe it, show the table status, the create table, and show the indexes. And so when I press go, there's our table with the 3 rows that I inserted. They have values of 1, 2, and 3 for the ID. And there's our describe. So that's the describe right there, the show table status, and the show create table. And you notice I also have a show indexes, but that's not giving us any results yet. So I'm going to change this create table here as we move along. In MySQL, an ID column requires that a column is defined with not null and unique index constraints. And so in MySQL, a primary key constraint, and this is actually true of many database systems, primary key provides both not null and unique, and it provides an index named primary. The effect is that there's only one primary key allowed per table. And so I'm going to go ahead and execute this, and you'll notice that down here in our show create table, it shows our create table as having a not null constraint and a separate primary key index. And down here in our show indexes, we have a key name of primary. And that's all just with this primary key here. We didn't say not null, we didn't say unique. So you notice that nulls are not allowed, and our index says non-unique is 0, which means that it's constrained to unique keys. So if I try to insert a duplicate row, I'm just going to copy this row here. So we have 2 of those with a 3 in here twice. You notice we get a constraint violation. Duplicate entry 3 for key primary. So that is in fact not allowed. So primary key gives us those requirements for an ID field. Current versions of MySQL do not require that the ID column uses the primary key constraint. Earlier versions of MySQL did require that. In most cases, an ID column fits the definition of a primary key. Because the ID column requires that every value is unique, MySQL provides a feature that will automatically generate sequential values for the column. So if I come back up here to my definition, where I have primary key, I can say auto increment. And this is a very common construct here, auto increment primary key. And when I press go, you notice in the describe, it now says auto increment in that extra column. And there's an auto increment here in the show table status. And if I come back here now and I take these values out, and I have to take ID out of the list there as well. So now I'm not inserting anything into that ID column at all, and I press go, and I still get those sequential values. Those are now automatically generated. So that's auto increment. MySQL provides an alias for all of this called serial. I can take all of this integer auto increment primary key, and I can just type serial and press go, and I get exactly the same result. The difference here is that the type here is big int 20 unsigned. And if I say integer auto increment primary key, you notice it's just an int 11. So if you have a lot of data, and if you're expecting to have a very large table, that big int unsigned is going to give you the maximum amount of space for those values. That'll allow you the maximum size of numbers for that column. So it's not such a bad idea. The serial shortcut is an easy shortcut, but you need to take your data storage requirements into consideration. In most cases, it's fine. It allows for very large tables. In practice, in an application where you might be concerned with the extra storage, you probably need the maximum size of an unsigned big int anyway. According to the MySQL manual, serial is just an alias for big int, unsigned, not null, auto increment, unique. Serial was added in MySQL 4.1, so it's not available in all the older versions, so most people still use integer primary key. When you're using an automatically generated ID, sometimes you'll need to know the ID column for the last inserted row. This is available from a special function, and I'm going to come down here right after the select from test, and the special function is called last insert ID. And you notice that I'm not specifying that it comes from a particular table. This is a database-wide last inserted ID. So if you're using this in code and you want to get what's the ID of this row that I just inserted so that you can use that ID for another purpose, you want that to be right after your inserts. So when I press go here, you see the last insert ID is 3, and you see that that is the ID of the last inserted row in the table. Just one more quick thing I wanted to show you. With this ID serial, you'll notice that our create table shows the ID as big int 20 unsigned, not null, auto increment, and with the unique key ID. And here the key is named ID. It is not named primary because we're not using the primary key constraint. So just so you know that that's what it does. MySQL provides comprehensive support for ID columns with the auto increment constraint and the special serial alias. This is a very useful feature. We'll be using it a lot in the rest of the course. I'm going to go ahead and drop this table now, bring our database back to its original state for the rest of the course.